Hello everybody, we've been working our way through the 2018 AP test. We're on our last problem. We're going to take a look at question number 6 today. This is question number 6 from the 2018 AP Calculus test. I've already gone ahead and done part A. Part A you won't need to worry about on the 2020 test, at least not in terms of drawing it. It just asks you to sketch the slope fields. They gave you a slope field here, and they want you to go through the 0.02 and through the 0.10. But down in B and C are where the problem gets a little bit more involved. So B says that we want to let y equals f of x be the particular solution to the given differential equation with the initial condition f of 1 equals 0. Write an equation for the line tangent to the graph y equals f of x at x equals 1. Use your equation to approximate f of 0.7. Now we know that we have the 0.10. So we know that we need a slope if we're going to find the equation of a tangent line. So in order to find the slope, we will be taking 1 and plugging it into our equation for the slope. So we are going to take 1/3 of 1 multiplied by 0 minus 2 squared. The 0 is because my y value is equal to 0 and my x value is equal to 1. This will equal my slope. So I would end up with 1/3 of -2 squared is 4, which equals 4/3. So my tangent line equation is going to be equal to y minus my y value is equal to my slope multiplied by x minus my x value. They ask me to approximate the value of f of 0.7. So I'm trying to find a y value. So I would say that y is equal to 4/3 of 0.7 minus 1. And this is f of 0.7 is equal to y, which is equal to this thing. And that would be my final answer for part B. Part C says to find the particular solution y equals f of x to the given differential equation with the initial condition f of 1 equals 0. This is a separable variables problem. So in part C, we start with dy over dx is equal to 1/3 of x multiplied by y minus 2 squared. And to get my y's with my y's and my x's with my x's. So I have dy divided by y minus 2 squared is equal to 1/3 of x dx. This is what I am then going to try to integrate. I want to get integrate, and then I want to get y all alone. So if I take the antiderivative of this, this is something raised to the second power. So if I increase the exponent by 1, I would end up with 1 over y minus 2. And then technically remember that this exponent would be a -1. So we would have negative 1 over y minus 2 is equal to, if I increase this exponent, this would become x squared over 6 plus c. Now I need to use my initial condition to find out what my constant is. So I know that if I take -1 over 0 minus 2, which is -2, that should equal 1 over 6 plus c. This is really positive 1/2 equals 1/6 plus c. 1/2 is 3/6, which means that C is going to be 2/6 or 1/3. So we now know that -1 over y minus 2 is equal to x squared over 6 plus 1/3. The last part of this problem asks us to get y all alone because they asked us to solve for y equals f of x. So that's what we're going to do to finish this thing off. Let's get this negative out of here. So we have 1 over y minus 2 is equal to negative x squared over 6 minus 1/3. And I'm actually going to write this as minus 2/6 because then I can write it as a single fraction. Then I have 1 equals negative x squared minus 2 over 6 multiplied by y minus 2. Then I can multiply by the reciprocal of this thing. So I have 6 over x squared minus 2 is equal to y minus 2. And so 6 over x squared minus 2 plus 2 is equal to y. And that would be my final answer. I have my equation in y equals f of x form. Y is all alone, which is what I want. I've solved for the constant based on the initial condition. Most of the points in this problem are going to be for separating your variables and integrating properly after you separate your variables. If you weren't able to follow getting into this last bit, that's probably only worth maybe a point or so. You also probably need to give some sort of exception that you wouldn't be able to have x be equal to the square root of 2. So you'd put like a x cannot equal plus or minus the square root of 2 because that would give you 0 in the denominator. But that's about it. Hopefully that was helpful, and hopefully people are feeling ready for the 2020 test. I look forward to talking to you all again soon. Be well, and have a good day.